Hello, everybody. Hello, everybody, and welcome to the 8 steps of hypothesis testing for regression. We're going to use the same example that we used in the regression computation video, the computation of the regression line video. So it's number 10 in your textbook, chapter 11. And when we're testing the 8 steps for regression, the wording that you might see on the exam is test to see if the slope is significantly different from 0. They mean the slope of the regression line. So let's go into our document camera and make sure you can see this. Okay, so the very first step of the 8 steps for us for regression is going to be that the slope, and it's a population slope, is equal to 0. And that's a beta, and it is a capital beta. And it looks like this, kind of like a bee with a little stinger on the bottom. Bee sting, right? This is equal to 0. And then, so we're saying that the slope of the line is equal to 0, meaning it's a kind of a straight flat line, a horizontal line. And if there's no slope, then that would indicate no relationship between the two variables. And so 2 is that the slope is something other than 0. Right? It could be negative, it could be positive, something other than 0. Step 3, state the alpha. Step 4, what kind of test is it? Well, it's changed on us now from correlation and others. It's now a regression test. And this, like ANOVA, is an F-test. So it's regression slash F-test. And then 5, the assumptions. The nice thing is that these assumptions for regression are the same as the assumptions that we're going to have for correlation. So X and Y are linearly dependent. And X and Y are approximately normally distributed. So there's our assumptions, same as correlation. 6, state the decision rule, but also find the critical value. This is an F critical. And like ANOVA, we have 2 different degrees of freedom. But this time, instead of between and within, we have regression and error. And DF regression, which I'm going to call DF reg, is always 1 for us. So DF reg will be 1, equal to 1. No formula necessary there. DF error is the other term. And that's just like the degrees of freedom for a correlation. It's n minus 2. So on the previous example that we used, number 10 in chapter 11 of our textbook, there were 9 total participants, or 9 total people. Minus 2 gives us a degrees of freedom error of 7. And then if we want degrees of freedom total, we just do DF reg plus error, or in total, kind of total number of people, n minus 1, which was 9 minus 1, which is 8. So we have 1 and 7 for our degrees of freedom. Now, if we want to go find the F critical, then we need to go and use the F table in our book. So come to the F table, page, again, 554 in the textbook. And instead of, now you see degrees of freedom for numerator, degrees of freedom for denominator. Way back when we talked about ANOVA, I talked to you about degrees of freedom for numerator in regression is the degrees of freedom regression. Degrees of freedom for the denominator is degrees of freedom error. So we had DF reg, we said, is always 1. So we're never going to leave this first column when we test regression. DF error is denominator, and that was 7. So we go down 7 over to 1, and here we have our F critical value, 5.59. So go back to our document camera, and our F critical is 5.59. Now the decision rule. This is similar to ANOVA, just if F observed, is greater than our critical value, which was 5.59, we reject HO, else we accept HO. So there's our decision rule, and now we're ready for the calculation. Now this one, you remember the setup for the calculation on ANOVA was kind of horrendous. This one, a lot easier. So we're still going to get our sums of squares total first. I like to do that first. But sums of squares total is equal to SSY. Now SSY, you might remember from the correlation, we got that value when we calculated the correlation. So I'm going to just bring back the data to show you when we did SSY for this data set. We got SSY from the sum of y squared minus n times y bar squared, and it was 60.25 when we calculated. So we're going to take that 60.25, and that is our sums of squares total. So pretty easy so far. Sums of squares regression is the one we're going to do next, which I'm just going to call sums of squares reg, and that is r squared times SSY. We have SSY above. R squared is just the correlation that we got when we tested the correlation between these two variables squared. Remember the correlation that we got up here is 0.96. So we're going to take that correlation and we're going to plug it in here, and we're going to square that correlation, and then we're going to multiply it by the product by 60.25. So 0.96 squared is going to be 0.92, and 0.92 times 60.25 gives us our sums of squares regression. By the way, I'm going to put boxes around these because we're going to need to create a source table, and I'm just going to make it easier for you to go find these. SS regression, 0.92 times 60.25 is 55.43. And then sums of squares error is equal to sums of squares total minus sums of squares regression. So total was 60.25, regression was 55.43, and so the sums of squares error is equal to 4.82. Now remember, sums of squares error, or sums of squares was the hard thing to get with ANOVA, and I guess you can say it's the hard thing to get with regression. But we're pretty much, I mean, we're almost done, and we really haven't done anything too terribly difficult. Mean square regression is equal to sums of squares regression divided by degrees of freedom regression. Now something interesting about this calculation, and if you learn this about the relationship between mean square regression and sums of squares regression, then you don't necessarily need this calculation. The sums of squares regression was 55.43. But degrees of freedom regression is just always 1. So mean square regression is the same as sums of squares regression, 55.43. So kind of once you calculate your sums of squares regression, you're going to have your mean squares regression. They're going to be the same thing. Mean square error is equal to sums of squares error over degrees of freedom error. Our sums of squares error is 4.82. Our degrees of freedom error, which we get from step 6, was 7. 4.82 divided by 7 is 0.69. And then our F observed is equal to mean square regression over mean square error. which is 55.43 divided by 0.69, which gives us an F observed value of 80.33. Now, if you're checking these against the answers in the back of the book, this one, more than any other one I've used as examples out of the book, is pretty far off of the answer in the back of the book. But I assure you, it's just because of rounding. Because we're rounding to 2 decimal places all the way back when we calculated the correlation for this thing, it's just altered the answer on down the line a little bit at a time to the point where we get kind of a bigger difference. But that the calculations are correct here. It just won't match the final answer in the back of the book due to rounding. Okay, and I'm going to leave a section for us to complete step 8 here. But what I'm going to do is just sort of indicate source table on back, right? Because what we need to do to finish up step 7 is to put in our source table. So 7 continued, and I just wanted us to have enough room to record these without too much trouble. Here we have source, same across the top, sums of squares, degrees of freedom, mean square F. Down the page though, now instead of between, we have regression. Instead of within, we have error, and then total's the same. So our sums of squares are regression, and I can just tell you what these are without us flipping back. 55.43. Our sums of squares error, 4.82. And our total sums of squares is 60.25. Degrees of freedom, regression is 1, always 1. Error, well, this time is 7. And total is, degrees of freedom is 8. And then regression, mean squares, the same as the sums of squares, 55.43. Mean square error is 0.69. We don't have a mean square total value, and we only have one F, so you can cross out these 3 bottom corners. And the F we calculated was 80.33. So there's our source table. Now let's go back and make our final decision about the slope, because F observed equals 80.33 is greater than, which we would have, you would have used the symbol, but I sort of ran out of room over here. But 80.33, you know, right, greater than, so this is greater than symbol, is greater than F critical, which we can get from up here, 5.59. We reject the null. So we're rejecting the statement that the slope is equal to 0. We say there is a slope to this regression line, and it is because of the way we calculated the slope in the other video that I showed you about the computation of the regression equation. We know the slope is positive. Okay, that's it for the 8 steps for regression. I'll see you for the pretest for exam 5. Thank you.